Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will study some more problems upon successive differentiation. So the problems that we will take up in this lecture are sin 2x and sin 3x, find its nth order derivative. Next is find the nth order derivative of sin x, sin 2x, sin 3x. Now first I am going to calculate the nth order derivative of sin 2x, sin 3x. Let us assume that y is equal to sin 2x, sin 3x. I am going to write over here the nth derivative of sine and cosine function. So if y is equal to cos of ax plus b, then what will be its nth order derivative? You know, here will be coefficient of x and n times, means a raised to the power n, cos ax plus b argument as such, and plus n pi by 2. Fine. And similarly, if here is y sin ax plus b, then what would be the case in this case? It will be yn, coefficient of x a, so a n times sin, it will be ax plus b plus n times pi by 2. Fine. So these are the nth order derivative of sine and cosine function, where argument is of the form ax plus b. Now look over here in this problem. We are given the product of two elementary sine functions. So to deal with that product, we don't have any direct nth order formula. So if there would have been only sin 2x, we could have easily written its nth order derivative, and if there had been only sin 3x, then we could also easily written its nth order derivative. But here is the product, neither there is plus sign in between, neither there is plus or minus sign in between, so that we could just take this derivative separately and then add up or subtract them. This is also not the case. Here is they are in product. So what we can do, we can just do one thing. We can write over here sin 2x sin 3x, and in case of 2 sin a sin b, what is the formula? And if you want, you can write it in this form. So now what will be the formula for this one? We know 2 sin a sin b is equal to cos a minus b minus cos a plus b. So we will be making use of this formula to find this one. So say this is a, this is b. So this will be 1 by 2. Now it will be cos a minus b. So it will be cos 3x minus 2x minus cos 3x plus 2x. So this will be further equal to 1 by 2. It will be cos x minus cos 5 x. So this is your y. Now what will be their nth order derivative? Y n is equal to 1 by 2 as such, and say this is, if I can write it as, or you can simply write nth order derivative of cos x minus nth order derivative, this form you can also write, of cos 5x. So what will be nth order derivative? You know, coefficient of x, it is in this case 1 dot x. So it will be 1 raised to the power n and cos x as such plus n times 5 by 2. Minus will be as such, coefficient of x is 5, so 5 raised to the power n, and it will be cos 5x plus n 5 by 2. Find and close the parenthesis. So this 1 multiplied n times, you know, 1 multiplied 1 multiplied with 1 multiplied and 1. This is done n times. So what will be the effective result? 1. So this is further equal to, you can write 1 by 2 cos x plus n 5 by 2 minus 5 raised to the power n cos, it will be 5x plus n 5 by 2 and close the parenthesis. So you will write over here yn. This is the required nth order derivative of the first function, which is the product of two functions. So in this problem we have dealt with, if we are given product of two elementary sine function and or cosine functions, then we can use the formula. If instead of this we are given like sine 2x cos 3x, then how will deal with it? It is very simple. You will do one thing. You will write, assume it as y. You will multiply it with 2. You will divide by 2. And you know 2. This will be assumed as a 2 cos a sine b. What is the formula? 2 cos a sine b. Sine a plus b minus sine a minus b. So this result we will use it over here, and with the help of this one we will write, this will be assumed as a and this will be assumed as b. So it will be sum of 2 sine, it will be 3x plus 2x, it is minus sine a is 3x minus 2x. So it will be 1 by 2, it will be sine 5x minus sine x. So this is your y. So in this way, product of any two elementary functions is given. If it is here cos 2x cos 3x, you can easily write, and after putting it up into this form where it is sum of two elementary function, you can easily calculate what is its nth order derivative. You can easily write yn is equal to 5 raised to the power n coefficient of x and sine 5x plus n pi by 2 minus 1 raised to the power n time, it will be 1 sine x plus n pi by 2. So this is the nth order derivative of this function. Similarly, you can also calculate cos 2x, cos 3x. This will be very easy. So now through the first problem we have dealt with how to deal with the product of two elementary trigonometric functions. Now we will move further towards the product of three trigonometric function, and this is this will be done on the same lines. Firstly, we will convert the product of two function into sum or product of elementary trigonometric functions, and then we will multiply the third one inside and again use the same formula, and we will try to get the result. So I am doing it. You will have a look at. Now we will take up the second problem, and second problem is y is equal to sine x sine 2x sine 3x. Fine. So you will do one thing. You will try to use the formula of sine A, sine B for any of these two product of elementary sine functions. So firstly, I am selecting this one. So this will be sine x, and formula used, you know, once again I am writing, you already know, sine A sine B is nothing but equal to cos A minus B minus cos A plus B. So we need to here, so I need to supply. Fine. So this will be 2 sine 2x sine 3x. Fine. So this will be further equal to sine x, but so you will write cos of, this will be assumed, greater will be assumed as A, this will be B, sine 3x minus 2x minus cos 3x plus 2x, and this will be closed in the parenthesis. This will be sine x by 2, and this will be cos x minus cos 5x. Fine. Now you will multiply this one inside. What you will get? 1 by 2 sine x cos x minus 1 by 2 sine x cos 5x. Now you see it is again product of two elementary trigonometric function, that is sine and cosine. This is also sine and cosine. So we again cannot use the direct formula for elementary trigonometric functions over here of successive differentiation. So we are again helpless. So what we will be doing over here is multiply and divide by 2. So it will be 1 by 2. 2 is already there, so it will be 4. 2 sine x cos x, it will be minus 1 by 4 again, 2 sine x cos 5x, and you know 2 sine A cos A is nothing but sine 2A means sine 2x minus 1 by 4, and what is the formula for 2 cos A sine B? This is sine A plus B minus sine A minus B. So you will using over here, this is assumed as A, this is assumed as B. So it will be sine 5x plus x minus sine 5x minus x. This is equal to 1 by 4 sine 2x minus 1 by 4 sine 6x minus sine 4x. This is further equal to 1 by 4 sine 2x minus 1 by 4 sine 6x minus minus is plus 1 by 4 sine 4x. So now this is in the form of that is difference of trigonometric sine function, that is sum of trigonometric sine function. So it is only power, having power 1, not a square, not a cube. So this is the elementary sine function with degree 1. So now we will be writing their nth order derivative. You know yn will be 1 by 4 as such. You can write dn by dx and nth order derivative of sine 2x minus 1 by 4 nth order derivative of sine 6x plus nth order derivative of sine 4x. So this will be 1 by 4 sine 2x. What will be its nth order derivative? It will be 2 raised to the power n, and sine 2x as such plus n times pi by 2 minus 1 by 4. It will be coefficient of x is 6 raised to the power n sine 6x plus n times pi by 2. And what's its nth order derivative will be plus 1 by 4. Coefficient of x is 4 raised to the power n sine 4x plus n times pi by 2. So if you want to take 4 common, you can take it. Otherwise this will be the nth order derivative of product of 3 functions. Similarly, on the same lines, using these elementary formulae, 4 formulae, we can calculate. If here we are given cos x, cos 2x, cos 3x, we can also do it on the same line. Firstly, we will deal with cos 2x, cos 3x, then we multiply inside and we will deal with the product of further 2 functions. So that is how you can also deal with this one. And if we are asked to find, look over here, that find nth order derivative of cos square x, you will assume it as y. Okay, you will assume it as y. But for cos square x, because if its power is degree is 2, we don't have any formula. So we need to convert it into degree 1. We know why. Cos square x is nothing but 1 plus cos 2x divided by 2. So I will do it. You will write it as y is equal to 1 by 2 plus 1 by 2 cos 2x. Now you will differentiate. First time it will be 0 plus it will be 1 by 2, it will be sine 2x, and here will be minus also. Fine. So why I am differentiating? Because here we will be putting the condition n is greater than or equal to 1. So now 1 by 2 will be constant, and cos 2x, similarly if you can put it into form, minus will be adjusted, 1 by 2, this will be sine will be converted to cos cos 2x plus pi by 2, and minus will be adjusted over here. Similarly, continuing likewise. Now we have done it because in n is equal to 0 there is 1 by 2, which after first differentiation have been omitted. So after by putting n is equal to 0 we cannot obtain the y back. So therefore we will be putting the condition over here. And what is that condition? Y by 2 will be 0. It will vanish after first order derivative. So what will be the derivative of cos 2x? It will be 2 raised to the power n cos 2x plus n times pi by 2. Fine, divided by 2. So this will be 2 raised to the power n minus 1 cos 2x plus n pi by 2, where you will put n is greater than equal to 1. So this condition is necessary. Similarly, if you are given to find nth order derivative of cos cube x, so how will you do it? We know the formula for cos 3x, so we will be using it and we will converting it with that help, with the help of that. And what is that formula? So I am going to write it over here, the formula for cos 3x. It will be 4 cos cube x minus 3 cos x. From here what will be cos cube x? This will go over here, so it will be cos 3x, this will be here, plus 3 cos x divided by 1 by 4. So by this we can easily calculate the nth order derivative of cos cube x. Similarly we will do with the sine. If we are given sine cube x, then what is the formula for sine 3x? It will be 3 sine x minus 4 sine cube x. So what will be the value of sine cube x? This will go over there, this will go over here. So this will be 3 sine x minus sine 3x and divided by 1 by 4. From here you can easily calculate the nth order derivative of sine cube x. Similarly, if we are given cos raised to the power 4x, so can you write cos cos 4 as cos square x and cos square x? You can use the formula for cos square x as 1 plus cos 2x by 2 and multiplied by 1 plus cos 2x by 2. Now we'll multiply them and we'll get the result, and whenever there is product you will use these formulae of sin A, sin B, cos A, sin B, cos A, cos B, and something like that. You will be using them and converting them as a sum of elementary trigonometric function, and then we'll be doing it. So with the help of that we can also calculate the nth order derivative cos raised to the power 4x and also sin raised to the power 4x. Sin raised to 4x can be written as sin square x and sin square x. And what is the formula for sin square x? That is 1 minus cos 2x by 2. So you will be writing here and multiplying them and using the result. So in this lecture we have studied 2 important problems and given hint for many other such problems involving the trigonometric functions in the product form or in the degree greater than 1 in the product form and in the degree greater than 1, like that, like here 3, here 3, here is 4. So we have dealt with them and find their nth order derivative. So that is all I have from this lecture, and I hope that you will be able to grasp the idea. Very soon I will be with you with my next video lecture. Till then, take care, bye bye, and see you soon. This is Dr. Rajesh saying you goodbye. Take care. Bye bye.